This topic will present the basic flow of Spirent TestCenter Automation. We've initialized the script and variables. We've connected to the chassis, reserved the ports, created our objects. Now we must subscribe to the results. Spirent TestCenter Automation API has two types of results, runtime and end of test. Runtime results are available while connected and the object is active. End of test results are written to the results database and are available after the script has completed. You could think of it as data model and database. So the data model is within the system and database is going to be after the fact and it will be written out to the database. End of test results not written to the database are lost upon disconnection and release. And the script must subscribe to any requested result. If you want to view it, you're going to have to subscribe to it first. The Spirent TestCenter API maintains a set of real-time counters that are updated periodically. You will use the STC subscribe API function to enable the result collection. A sample of that code is presented. A few of the available real-time results include port statistics, CPU statistics, diff-serve, overflow, stream group. There are others. This is a sample of them. Before we look at the actual code that will describe the result subscription, let's take a look at the documentation. Within the Spirent TestCenter Automation Programmer's Guide, we will find the subscribe API function. Within there, it provides the syntax. For example, subscribe -parent handle. You'll have to put in the object handle that you want to go and receive the information from, and the result type. Just beneath that subscribe definition within the Spirent TestCenter Automation Programmer's Guide, there are the list of result types. And we've listed three of them for you directly underneath it, and one of them is the analyzer port results. Now, within the Spirent TestCenter Automation Object Reference document, you will have to go and look for the analyzer port results object. Here we have the actual code. You'll see that we're starting with the STC subscribe API function. Our -parent handle is the project. We're looking for the project handle. Our configuration type is analyzer, and our result type is analyzer port results. And you'll also see file name prefix. Well, that's the name of the file that the system will create automatically when this test is executed. You'll see that we performed a putS command, just stating that we have subscribed to the analyzer results. And then we've performed the exact same thing with the generator, only we're using the generator. Configuration type, result type is generator port results. Now the interval is the time in seconds that the results information will be updated. Now the default is 1. So in this example, we want to set it to 2, so every 2 seconds, whereas for the analyzer, since we did not specify an interval parameter, it will default to 1 second. The Spirent TestCenter Automation API also provides the option to get the port results using the STC get API function. As shown, STC get analyzer port results 1, for example. This statement will return an array which will have counters for the attributes such as frame count, bytes received, etc. You'll see our snippet of code. The subscribe API function automatically will apply the subscription to the Spirent TestCenter hardware. Now you can still use the STC apply API function to manually upload any additional configuration changes if you would like. We now want to start the test, start transmitting the traffic. But we're going to start the analyzer first using the STC perform API function. We want to start the analyzer so we can make sure that it can receive the information, the traffic that is being generated by the generator. Then we want to start the generator afterwards. And then the sleep API function suspends your application as specified in seconds. If we look at our sample script, we're performing a putS saying we're starting the analyzer, and we perform an STC perform analyzer start, and then the analyzer list is we're looking for the analyzer object handle. Now the sleep function will just basically suspend the application for 2 seconds, and then you'll start the generator. using the commands as shown. It's really the same type of command, only you're using it for the generator rather than the analyzer. And then finally, we perform a put-s, just stating, hey, we are now transmitting packets. Once all of the traffic has been sent, or after a period of time defined by the script, you will want to stop the generator and then the analyzer using the STC perform API functions. You'll see the two commands, perform analyzer stop and generator stop, and then we've just shown you the actual example in our snippet where we're going to specify STC perform, generator stop, and then the generator list is the generator object. That's $H generator. We're going to suspend the script for 1 second, and then we place a put-s command stating that the generator stop command was issued, and then we perform the exact same thing for the analyzer. And then at the very bottom, what we're doing is we're just going to check and display this to the screen of the current state of the generator and analyzer. Now we want to gather the results. We will gather them from the results subscription specified previously using the STC get API function. You can retrieve any value that is stored within the subscribed value. Previously, in this subscription, we wanted to access the analyzer port results. And I showed you that basically we were going to look at two items, SIG frame count and total frame count. This is as presented within the documentation. Now we're going to display it in our sample code. What we're doing is we're creating the handle for the analyzer results. We are going to perform the STC get on the analyzer object handle. We're looking for the children of analyzer port results. And then we do a put-s statement of displaying frame count. And now you'll see we do another put-s, and the /t is just a tab, signature frames, and then STC get analyzer results handle that we retrieved earlier, and then -sig frame count. You can also gather end-of-test results from the SQLite database using the STC perform API function. You'll see within our snippet of code, we have the STC perform save result. Basically, we're going to save the file, and we're going to call it results_via API.db. The SQLite 3 DBL results, that's actually going to populate it. And then you'll see set DBL result, DBL eval, and then we're going to look for the total frame count from the generator port result. You can also clear the protocol, traffic, or the results using the Automation API clear commands. As shown here, we have the results clear all traffic command, and this will clear all traffic results in the system. Now for our example script, it's really not necessary because we're creating the objects, we run the traffic, and then we clean up the script, and that's it. We've run the traffic, we've gathered the results, now we must clean up the script. We will release any reserved port groups using the STC release API function. Port group may contain more than one port. Any attempt to use a port handle after it has been released will result in an error. We will disconnect from the chassis using the STC perform API function, and then you will have to delete the project object to release any resources accumulated through the use of the API using the STC delete API function. In the sample code, you'll see that we release the ports on the transmitting and receiving side using the chassis, slot, and port triplet. We disconnect from the chassis using the disconnect API function, and then we delete the project. We will now take a look at some of the surrounding elements within the scripting environment. The Spirent TestCenter Automation API allows you to specify system logging by using the STC config API function, and you will use that to configure the automation options object. So you can specify the message type as well as display the messages to the screen or to a file. Now in this case here, you'll see we have the STC config automation options. The log level is going to be debug, and the log2 is we're going to write it out to the debug.log file. Here in our examples, you'll see the sample code, which level is debug, and the log2 is debug.log. When we run the script, we look in my documents, and you will see that the system created a debug.log file. And if we open that log file, you will notice that it has the debug messages that were obtained when the script was executed. Now on the right side of the screen, we'll see the sample code, and instead of going to the debug.log file, you could have named it anything you want to. That was the name we chose. You could select standard out, and in that case, the output of the debug would be submitted to the screen and displayed to the screen. It's the same information, only it's going to be either written to a file or written to a screen. Now you're not going to be able to do both. You can do either one or the other. The last item of discussion within this topic is capture. The Spirent TestCenter Automation API supports the Capture Object option that allows you to capture packets on a receiving port. When you created the port object, the Automation API automatically created a Capture Object. Therefore, the script must retrieve the Capture Object handle before setting the capture configuration. You will use the stc config API function and the capture object description to specify the items that you wish to capture. You will use the stc perform API function to start and stop and save the captured data. Here within the capture code, you will notice the first thing we are doing is retrieving the capture object handle. We use the stc get command. We want to find the H port, RX, the receiving port handle, and then we want the children and then the capture of the children. Then once we have the capture handle, we can perform the config command on the H capture or on the capture object handle. And then you'll see the mode is regular mode and the source mode is transmit receive mode. We then will perform capture start, and you'll notice that we are doing the capture proxy ID, and then we're pointing to the capture handle. And that's basically configuring it and starting it. In the bottom portion of the code, now we will stop capture, so we do a stc perform, capture stop, and once again, the capture proxy ID attribute, and then the object for the capture object handle. We place in a put s capture stop, saying that it's stopped. Now, if we want to save these frames to a file, we can use the stc perform capture data save. We're specifying a file name. In this case, we're calling it capture.pcap. File name format is pcap, and then the ISSCAP is false. And once again, some of these items may be defaults, and some of them may be uniquely set. Finally, you'll see display capture count to screen, where we just want to, in this case, display how many captured files we actually have gathered. And in this case, after the put s statements, we perform an stc get on the object and the capture object, and then we're just looking for the dash packet count. So once again, you would have to look in the documentation under the capture object in the object reference, and you could see what attributes you can access.
Thank you. This completes this video presentation.